Hello everyone, welcome back to my YouTube channel, and today's video is on solving Chinese Postman Problem, a fascinating topic in graph theory. If you are studying data structures and algorithms, this is an exciting challenge that blends mathematical theory with practical applications like optimizing delivery routes or planning efficient travel paths. But before diving into the problem itself, let's first lay the foundation by talking about graph theory, as it's crucial to understand the Chinese Postman problem. Graph theory helps us model and solve real world problems like transportation networks, communication systems, and even social connections in this video. We'll explore how graph theory is directly linked to Chinese Postman problem, step by step. So let's start with the basic of graph theory and build up from there. Because understanding graph is key to solve the CPP. What is a graph theory? A graph theory is a branch of mathematics and deals with graphs, which are structures made up of nodes, also called verticals, connected by edges or arcs. It is used to model relationships and systems like social network, transportation systems, and computer networks. Essentially, it helps us understand how different elements are connected and how to traverse or optimize paths between them. Now let's move on to the key concepts of graph theory. To understand the Chinese Postman problem, let's go over some key graph theory concepts. And these are some key concepts in graph theory. Undirect graph. Edges do not have a direct meaning. The relationship is bidirectional. Direction graph. Edges have a direction indicating a one-way relationship. Degree of vertex. The number of edges connected to a vertex. Eulerian path. A path in a graph that visits every edge exactly once. Eulerian circuit. An Eulerian path that starts and ends at the same vertex. So now let's move on to the Chinese Postman problem. So what is the Chinese Postman problem? The Chinese Postman problem is a famous problem in graph theory. It asks, given a graph representing a city with roads, edges, and intersections, vertices, what is the shortest route that visits every road at least once and returns to the starting point? The goal is to find the most efficient route for the postman. Hence the name. The problem is specific case of Eulerian path problem. Now let's talk about Eulerian versus non-Eulerian graphs. A graph is a Eulerian if it has a Eulerian circuit. Means it's possible to start at one vertex, traverse every edge exactly once, and returns to the starting vertex. A graph is non-Eulerian if it doesn't have an Eulerian circuit. In fact, a graph can either have no Eulerian path, an Eulerian path, a Eulerian circuit. This distinction helps us know what approach to take when solving the Chinese Postman problem. Now let's talk about the steps to solve the problem. You can see the steps to solve the problem. The first is to check if the graph is Eulerian, and the second is to identify the odd degrees vertices if the graph is not Eulerian. Third is to pair odd degree vertices in a way that minimize the extra distance added. Fourth is to find the shortest paths between paired odd degree vertices. Fifth is to add edges to make all degrees even, creating an Eulerian graph. And the sixth is to find the Eulerian circuit, which will be the shortest route that covers all edges. Now I'll give you a brief explanation of the steps. Step 1. Checking if the graph is Eulerian. To start solving this Chinese Postman problem, we first need to check the graph is Eulerian. This is crucial because a graph has a Eulerian circuit. If all vertices have an even degree and are connected, a graph has an Eulerian path if exactly two or vertical vertices have an odd degree and the graph is connected. If neither condition is satisfied, then the problem doesn't have a solution, has a Eulerian path or circuit. And step 2. Next we look for the vertices with an odd degree. These are vertices that can be part of Eulerian circuit. In the Eulerian path, there should be exactly two odd degrees vertices, the start and end points of the path. If there are no odd degrees vertices, The graph already has Iranian circuit and the problem becomes easier. The step 3. Pairing odd degree vertices. If there are exactly two odd degrees vertices, we simply connect them directly. But if there are more than two, we need to pair them. The idea to find pairs of odd degrees vertices and create paths between them, it ensures every vertex ends with an even degree. This will allow us to convert the graph into one that has Iranian circuit. And the step 4. The shortest path calculation. Now comes the circuit steps. We need to find the shortest path between all the paired odd degrees vertices. The goal is to minimize the distance added when pairing vertices. This can be done using algorithms like Dijestra's algorithm and Floyd-Warshall algorithm, which help us to find the shortest path between two vertices in weighted graph. Once the shortest paths are calculated, we can add these paths to the graph and then traverse it to get the solution to the Chinese Postman problem. Okay, now let's do an example. I have given a graph. Now let's solve it by step. Step 1 is to identify odd degrees vertices because an Iranian circuit exists only when all vertices have even degrees. Okay, now let's look at the graph. So we can see is A is even and B is odd, C is also odd, D is also odd and E is also odd. And so the F is even. Since we have odd degree vertices, we must add duplicate edges between them to make all vertices even degree. Step 2. Find the shortest path between odd degree vertices. As you can see, I have paired BC and DE with 3 and 4 values and BD and CE with 3 and 3 values and B and CD with 6 and 6 values. And we must add the pairings. Now we can see that BD and CE is the shortest path. Now we can see that BD and CE is the perfect pair because it's the smallest value. Now we should add the total distance plus the smallest distance, which means we should add 6 plus and the total distance. The total distance is 24. After adding it, we can get the value 30. And so the Chinese Postman problem is solved. The shortest route is A to B, B to C, C to F, F to C, C to E, E to F, F to E, and E to D, and B to D to B, and B to A. Let's talk about why this is important. The Chinese Postman problem is used in real-world applications like postal delivery, garbage collection, and road maintenance, where a route must be planned to cover all streets efficiently. Duplicating the shortest edges between odd degree vertices, we minimize extra distance traveled while ensuring all streets are covered. So now let's move on to the code explanation. I have written a code in Java. It represents the graph that I did now. In the 9th to 18th line, we have the class initialization and variables. The class Chinese Postman problem is initialized with a graph, which represented by a 2D adjacency matrix. Each cell graph bracket I bracket j stores with the weight or distance between nodes I and j. The number of vertices in the graph is stored in num vertices. We also define INF as a constant, representing an unreachable or infinite distance between nodes. The constructor initializes the graph and the number of vertices. In 21 to 39 line, we have the Floyd-Warshall algorithm. We implement a Floyd-Warshall algorithm to compute the shortest paths between all pairs of vertices. This algorithm helps us to find the minimum distance between any two nodes, even if they are not directly connected. The algorithm initializes the dist matrix with the direct distance from the graph, and if two nodes are not directly connected, they are set to INF. It then iteratively updates the matrix to find the shortest paths through intermediate nodes. In 42 to 52 line, we have the calculate edge sum method. The function calculate edge sum calculates the total weight of the edges in the graph. This is the sum of all the direct distance in a graph. We loop through the graph and add up the weights of the edges. Note that we only consider the upper triangle of the matrix to avoid double counting edges. In the 55 to 62 line, we have the find odd degree vertices function. It identifies all the odd degrees vertices in Chinese Postman problem. We need to pair up the odd degree vertices in such a way that we minimize the additional distance added to the route. We calculate the degree of each vertex by counting how many edges are connected to it. If the degree is odd, we add the vertex to the list odd vertices. In 72 to 102 line, we have the find optimal pairing of odd vertices. After finding the odd degree vertices, we need to pair them up in such a way that the total additional cost is minimized. We used an brute force approach to find the optimal pairing where the cost is the shortest path between the vertices. In find optimal pairing function, we call a recursive function pair matching to pair up the odd vertices. It tries to every possible combination of pairing, and for each pair it adjusts the cost of the shortest path between them. The result is the minimal additional cost needed to connect all odd degree vertices. And 108 to 116 line, we have the Chinese Postman function. The Chinese Postman function calculates the optimal route cost. It computes the shortest paths using Floyd-Warshall, finds the odd degree vertices, calculates the total edge weights, and then adds the minimum cost of pairing the odd vertices. And we return the total route cost by adding the edge sum and the minimum pairing cost. And finally, we have the main method where we test the implementation using a sample graph. A graph is representing a weighted undirect graph with 6 vertices. We'll calculate the print the minimum cost to complete the route. As you can see, this is the output of the code. To wrap the things up, the Chinese Postman problem is a perfect example of how graph theory can be applied to real-world challenges. By understanding a key concepts like Eulerian paths and circuits, identify odd degrees vertices, and using shortest path algorithms, we can transform complex problems into manageable solutions. We have covered the steps involved in solving the problem, from checking if the graph is Eulerian to pairing odd degree vertices and calculating the shortest paths. Now you have the tools and knowledges to tackle not just Chinese Postman problem but also other graph related to challenges in your algorithm journey. I hope this video helped you to understand Chinese Postman problem. So don't forget to like, subscribe and stay tuned for more content. See you in my next video.